So question 11, it's all about getting your drawings correct. It's about making the drawing, and I think that's where a lot of people sometimes struggle with this. What's happening here? So you've got force acting that's pushing this 40 newtons this way. Of course you've got the gravity there, that's 3 kilograms. It's pulled down, another particle here, and this is 2 meters above the ground. Here we've got the weight of 2 kilograms there, so again we've got force coming down here. And if that's 2k kilograms, you can also work out what force is there. And then if you keep reading through, it says there's a friction opposing this force here of 8 newtons, and of course then we've got the tension there and the tension there. And so we've got a diagram described this way, and then you're going to work out which direction is positive. Let's call it that way there, so we're going that direction. And so getting the diagram is really important, and that will solve it all for you. Well, I won't solve it because I've got to solve it, but here goes. Show that the magnitude of the acceleration of each particle is 2.48 meters per second squared. So I've got to find the acceleration, and so resultant force is going to be the mass times the acceleration. That's old Newton law. So I'm going to do it for P and I'm going to do it for Q. So this is our P here, and that's our Q here. So let's just look at what happens at P. So I'm going that way, but I've got to take away the 8 newtons and the tension. So it's 40 minus the 8 minus the tension, and that equals mass times acceleration. So the mass is 3. And then here, because I'm going this way, it's T minus the 2g, because the gravity is pulling this one down. So T minus 2g equals, and it's 2 kilograms, so it's 2a. So they're the ones I need. That's how you do it. Simultaneous equation with this one. Adding these together, you get 32 minus 2g equals a, and therefore you can work out what a equals. And it says right at the beginning, treat g as 9.8. Obviously that's quite rounded up, make it more accurate. You have more a better gravitational one, not just 9.8. But if you did this, you get your 2.48 meters per second squared. That's part A. Now let's for part B.